So we are at the other senses, and this would be lecture 4 for AP and dual credit science psychology over. I got to figure out what I'm teaching first. This is lecture 4 over unit 3 for AP and dual credit, while at the same time, this would be part 2 of lecture 3 for on-level psychology. So we're going to go over the other senses. We've already talked about hearing. We've already talked about vision. And now we're going to take a look at touch, taste, olfaction, which is smell, and our kinesthetic sense, which is knowing where our body is and that control of it. Which again is not touch, but it is a sense. So there is a sixth sense that we have. So we've already talked about eyesight. We've already talked about hearing. And again, these are the most important senses. Without a doubt, vision is the go-to sense. We will allow what we see to impact what we hear, how something tastes, all these other things. Eyesight is the number one, then hearing comes into a close second. These are the most important senses, take up much more of our overall sense brain cerebral cortex than the other senses do, including our sensory cortex. Whereas other animals may not have as much dedicated to that, but may have more of their sensory cortex dedicated to something like smell, so that their smells become more enhanced, but just the fact that they're able to do those calculations faster. Dogs, sharks, larger part of their sensory cortex dedicated to it. Sharks can smell blood from about a quarter mile away. Bloodhounds also can sort of trace somebody over miles, although strangely enough, to show the nature-nurture thing, bloodhounds can't tell the difference between identical twins. Who knew? Now, when it comes to our other senses besides vision and besides hearing, let's start with our sense of touch. We basically have 4 sensations when it comes to touch: pressure, warmth, cold, pain. Those are the 4. So pressure would be as my hand is right here and I put this little marker on it. The pressure that my hand feels, that is the sense of touch. All right, I'm feeling pressure that wasn't there. Now it's there, not there, now it's there. Also, warmth and cold. And a lot of people get this a little bit confused because warmth and cold, because I go, but I can feel when things are hot. So where's my sensation of heat? Well, heat is just an extreme. Warmth is in the middle. Cold is an extreme, cold. But when you combine the warmth and the cold together, it becomes hot. You see these 2 tubes of water. I have a tube of cold water and a tube of warm water. Those 2 tubes come together, and suddenly it is piping hot. So all sensations are a combination of these 4 things. Oh, I'm sorry, and the other one's pain. Which is making the body uncomfortable, so it's something we want to get away from. So all sensations, combination of these 4. And we're more sensitive to things that we can't control. If I can control it, my senses just adapt to the shirt that I have and everything else. But when it's something I can't control, I'm a little bit more sensitive to it. For example, somebody tickling me, that's movement and that's pressure. But it's pressure I can't control, so I'm a little bit sensitive to it. You can't tickle yourself. Oh, you can try, weirdo, but you cannot tickle yourself because you can't control that movement and you're aware of where it is and everything else. A lot of times what we'll do, because these are the 4 sensations, is we'll try to counter-stimulate ourselves. For example, if you stub your toe on something and it hurts and it's and now suddenly I have pain. Let's say I hit something, I have pain on my hand. What I'll do is I'll take my other hand or I'll rub it. So now I'm paying attention to the pressure. So the pressure trumps the pain. Or I will put ice on it. And again, ice, well, it lets the swelling go down. Yeah, but I'm also now paying attention to the cold. I'm not paying as much attention to the pain. So that sort of counter stimulation that goes on. Touch is incredibly important, unmistakable in development of babies. Babies are getting nothing when they're little fetuses inside there. They're just getting warmth and stimulation all the time. And they come out and suddenly it's like, yeah, it's all the cold air and all these other things coming on their skin. That's why it's very, very important for babies to be held, to be massaged, especially premature babies. A lot of people will volunteer especially people in retirement homes, will volunteer to go to hospitals and sit there and hold little preemie babies because they need that sense of touch. We yearn for touch. And when we don't get touch, we're sad. They did a study where they took monkeys away from their mothers and they were never given that nurturing. And these monkeys were sad and maladjusted, which we'll talk a little bit more when we get to human development. Now, when it comes to pain, pain is good. You know, it's not like, oh, you know, it's not that good, but pain is good because pain tells you something's wrong and I need to adjust. If my butt was hurting right now, then I would get up and I would move in my chair because that pain is telling me your blood flow is stopping. So you need to get up, walk around, shift positions, whatever. There are some people who are born without without the sensation of pain, which may sound like an amazing thing, but the problem is when they've got like a little internal injury or some small injury or whatever, they're not going to know it. And then that little injury or infection or whatever can grow, and then that becomes a problem. When you think of Christopher Reeve, who was the original Superman back in the 70s and early 80s, fell off a horse, fractured his spine, quadriplegic, so he had no sensation from the neck down, and died because of complications from bed sores. Because he didn't know he had bed sores. No signals were getting up to his brain about the skin and everything else. Now, on the other side of the equation, you could have chronic pain where people suffer from, you know, backaches, headaches, arthritis, but is it mental? Because again, if we can create signals of pain, then can't we also get rid of those signals of pain as well? It would seem to make sense. So there's the brain with pain, if you want to pause and take a look at that, or take a look at anything there as well, or go back over the PowerPoint. Now, again, when we say that pain is mental, when people are amputated, 7 in 10 amputees may feel pain in a missing limb. So you take my hand right here, let's say this finger amputated. All right, so this is my right hand. There's different parts of my left sensory cortex that is dedicated to each of these fingers. If this finger is no longer there, there's still part of my sensory cortex dedicated to this finger. So what happens? Does it go dark? Absolutely not. What happens is the part of the sensory cortex that was dedicated to this is going to start to become more dedicated to the others and make up for it. But until that happens, it's going to take a while for my brain to make that adjustment. So I may feel what is called phantom pain, which means that even though this finger wouldn't be there, I could still feel like something pricked my finger, or my fingernail came off or whatever. A lot of people, when they get amputated, their legs, whatnot, as their brain is making a readjustment to sort of rewire itself, it's very possible that they'll feel pain of a limb that's not there. And so what they'll do is something called mirror therapy, where I will show the reflection of this missing hand by showing my other hand, and then any cramps or whatever you can sort of work out during that time. Pain is very interesting when it comes to memory, because pain will reproduce painful memories that a lot of times we can't remember something until we're put into that bad situation again, and it sort of goes back to it. There was a study where people were shown pictures, and while they were shown pictures, their hands were put in this bucket of ice water, and the thought process there was, well, they'll become so distracted by the ice water that they won't remember what they see. But it was actually the opposite came true. The pictures that they saw where their hands weren't in ice water, they didn't remember as much, but when they were in pain, they're like, oh, I'm going to remember this because this hurts and it's dangerous. So all these things are associated with that danger. So the brain is needed, and the brain, again, will rewire in the same way that if we lost our vision, our occipital lobe doesn't go dark, it rewires and it helps the temporal lobe, so that the things we hear we're more sensitive to. It doesn't give us super hearing where I can hear from 5 miles away now, but what I do hear I can process faster. Since I can't see, suddenly my brain is going to be more dependent on the tips of my fingers to read Braille. So somebody who's blind can read Braille easier than someone who has vision, because their brain is kind of dedicated to do that now. So when it comes to pain, again, there's what's called gate control theory. So as all these signals of pain are coming up to our brain in order for us to interpret them, it's very possible that we can block those signals through with endorphins, or counter stimulation, or putting ice on something that hurts. People with acupuncture, if I give you all these little painful signals here, then you don't feel the back pain or something else. Sometimes we could think away the pain, become distracted by other things. A lot of studies will show that people who have hospital rooms with windows don't need as much pain medication because they're distracted by the little birds outside or whatever. When all we do is think about the pain, you got a two things, oh, I do, and all we do is think about it, it's going to hurt more. It's going to hurt more. And again, the entire theory behind the idea of Lamaze, which is natural childbirth. I don't want any medication. Well, the entire thing that you have to do now is you got to distract her so she's not thinking of a small alien being ripped out of her body. Think away the pain. Good luck. Taste sensations. Again, we're talking about the tongue here. There's other parts of our body that do have particular taste sensations. Our kidneys are one. But not that we can consciously recall that, but that's how they sort of test the body. And it's gross, but what your kidneys do is your kidneys taste your urine to make sure that it's at a proper pH balance, whatever it is. But we're worried about the tongue. All right. And ironically, me talking about your kidneys tasting pee threw off your taste a little bit right there. We've got basically the sensations of sweet, sour, salty, bitter. All right, these are our taste receptors. They change every couple of weeks. As you get older, you become less sensitive, which is why young kids don't like spicy or overly sour foods or foods with a lot of taste. If you've ever eaten baby food, it's very bland. Kids will always complain, oh, that's too spicy. People who smoke, people who drink, their taste tends to get decreased because clogging up your sinuses and also sort of covering up your tongue there. Some other things there on taste. But more than anything else, taste is very much a user of what is called sensory interaction. A lot of how something tastes is how it looks, which is why if you ever watch something called Cupcake Wars, and the idea that they're saying that war is going with pastries, but their idea is, how does it look? What is the presentation? The taste of it is only part of it, because the way that it looks and the anticipation and all these other things have much more of an effect on taste. Studies show that every Skittle is the exact same flavor. Every Skittle is the exact same flavor, but you eat the purple ones and they taste a little bit more grape, they take a little bit more limey, a little bit more lemony, a little bit more cherry, a little bit more orange, because we think that's what we're tasting. So our mind's interpretation, when you go and eat a Big Mac, it doesn't have to taste exactly like a Big Mac, but if it's close enough, it goes with your memory of previous Big Macs. Texture of food, all these other things. That's why, when you're a kid and you got to eat something you don't want to eat, you may mush it up. You may combine it with other food. You may close your eyes. You may plug your nose, whatever. All of these things have an impact on taste. As a matter of fact, 80% of taste is based on smell. So smell is a little bit more important than your little taste buds there. Now, when it comes to olfaction, which again is the sense of smell, we take nearly 20,000 breaths a day. We got 5 million receptors right up here at the top. And unlike vision, that comes in shapes and sizes. And depending on what it's put with, it's going to change the smell. It's like a letter. Here, the letter A in the word chemical has that O sound. But if you take a look at the letter A with a D and a Y, it becomes a long day. So depending on what letters you combine the A with, it'll give you a different characteristic. And smells are the same thing, where a perfume or a cologne may smell one way with one person's body chemistry, may smell like something else with someone else. And that's why when somebody's putting perfume together or deodorant together, they'll try it on many different people. They'll try many different combinations, because this lavender may impact honey this way, but then honey gets something else pulled out of it by some other property by combining it with violets. I don't know what smells are. Okay, but again, you're taking all these little things, and a lot of smells are really hard to describe, but they're very much connected to memories. We can smell a certain perfume or whatever, and it can take us back to an ex-boyfriend, girlfriend, whatever, not else. Emotions go with it. Uh, you know, a lot of times when you get back to a smell, you know where you are. My grandparents' house had a certain smell to it. It was like Brock's candy and Bengay and Avon products. It was a potpourri of that. But I could close my eyes. Yeah, my Grammys. I just knew because their house had a smell to it. And it's not that it was bad. It was just I knew where I was with that smell. Now, interesting thing is a lot of animals will communicate through smell and again have more of their sensory cortex dedicated to it because other areas aren't as good. Ants don't have great vision, but they can follow other ants because they're leaving little pheromones behind and they're leaving trails. Bees that pollinate will leave pheromones behind to say, I've already taken care of this particular one. Dogs peeing on something and claiming territory by urinating on a certain thing or smelling where another dog was, and sort of we're going to each other and smelling their butts or whatnot, right, Stevie? Talking to my dog over. Come here, Stevie. Stevie, come here. Talking to my dog who also has these pheromones. Come here, baby. Come here. Come here, Stevie. Come. Here's my big girl. So this dog right here, what she has is more of her sensory cortex, as she's smelling and licking me right now in my ear, weirdo. She has more of her sensory cortex dedicated to her nose than I do. And her vision is okay, her hearing is okay, and probably the same as mine. And again, she doesn't necessarily see the same colors that I do, but what Stevie can do is she can smell much better than I can. So when she hides a chew, she may not know where it's hidden at, but she can smell around, and that's going to help her with that particular memory. Okay, baby? That's a good girl. Okay, go away. All right. Now, when it comes to humans and pheromones, we tend to release pheromones through sweat, which can be picked up subliminally by others. We can't consciously pick up pheromones. They just kind of give us a feeling. And again, it triggers something in our hypothalamus or our want center, and it gives us an emotional response. It's the reason that babies are more attracted to their mothers when they're little babies is because they've been inside of the belly marinating there for 9 months. They're used to those chemicals. They're used to those pheromones. Interesting thing, this just cracks me up the more I read about it. Not that I'm reading volumes or novels on it, but women who live in close quarters will gain similar menstrual cycles. So when they live together for 2, 3, 4, 5 months at a time, they all sort of and they click. And the interesting thing about this is that whoever is the most dominant female, the alpha female, she won't change. Everybody else changes to her, which is very, very peculiar. And as a man who's lived with, 3 girls under the same roof at the same time, it's kind of true. Now, other interesting things about pheromones, and these are interesting studies, girls whose fathers are around tend to reach maturity later because they've learned to reject male pheromones. And this is an old thing back to caveman days to stop incestual relationships. Whereas a woman whose father is not around and doesn't have boys around are more attracted or more susceptible, I guess you would say, to pheromones. Male sweat can have an impact on a woman's cycle. Women tend to feel more relaxed with the pheromones of their significant other. A lot of reasons why women will like to wear the jackets or the shirts or the whatever. But again, the jury's still out on this. There's no real definitive answer, but it's interesting. Kinesthetics. Kinesthetics are interesting because this is our sense of body movement and our position. We got 200 muscles in our body, but it's how do we have certain coordination? And this is our kinesthetic sense, my ability to not just touch and feel, but to control my body, to know where my body's at. You see this person right here in this picture. You put your hand over your head, you can, without looking, you can touch your fingers because you know where it's at. Now, again, I can't see it, I can't feel it, there's no pressure there, but I know where my body is located and how to do it. It's my coordination. And again, some people have an amazing kinesthetic ability and some people not so much, which is why some people are really good dancers and some people not so much. And again, you could have a kinesthetic ability in one area, but not necessarily someplace else. You could have someone who's an amazing drummer and they've got this unbelievable rhythm, but then you put them on a dance floor and they can't do it with their legs and their feet. All right. So again, this kinesthetic ability is my ability to just basically be able to control my body. Athletic ability, all things like that, that falls under this kinesthetic ability. And again, it's not touch because I'm not touching something, it's controlling what I am with my various muscles. And there's a little review right there, stuff right there. So that wraps up AP Dual Credit Unit 3, Lecture 5. And also that's part 2 of Psych L Unit 2, Lecture 3. And that should get us through. And now I got to go feed my dog since she is part of it.